Last time we looked at complex derivatives. Now we're going to look at the chain rule. Now the difference between a complex derivative and a chain rule involves a function within a function. If you remember from pre-calc, we have something called function composition. Let's say we have a function f, and inside that function f we have another function g. We have the chain rule. Now that's kind of very general. We're going to look at some specifics, obviously. But in general, when you have a function within a function, that's when you use the chain rule. Let's take a look. Here's f of g of x. And right off the bat, we're going to just learn the chain rule together. Usually you just have 2 or 3 layers. You can do infinitely many layers. You can do 4, 5, or 6. But when you have 2 layers, let's say you have g of x inside of f of x, here's the rule. You do f prime of g of x. So what does that mean? Well, first of all, you'll find the derivative of whatever the function f is. Whatever that derivative is, you actually plug the function g in for every time there's an x in your derivative function. So you can already see it is a little complicated of a rule, but we will learn this, and don't worry, it's not that hard once you know the formula and you apply it. Follow the steps. And then it's f prime of g times g prime. So again, that's the derivative of a function inside of a function where g is inside of f. Now when you have 3 layers, namely, let's say you have an outer function and then a function inside that and a function inside of that, this is your following formula. F prime of g of h, so basically you take the derivative of the outside, you plug in whatever's left over. Then you multiply by the derivative of the inside, you plug in what's left over after that, the 3rd layer. And then after that, you multiply by the derivative of the 3rd layer. I'm going to show you the long way and the short way, just because when you first learn it, you need to know the long way, labeling them. Once you get good at practicing it, I think it'll be easier for you to do the shortcut. So verbally, the chain rule states that the derivative of the outside times the derivative of the inside times the derivative of the inside of that. That's why it's called the chain rule. It's like a chain of events that happens when you take the derivative. For a 2-layer function, it's f prime of g times g prime. We already talked about that. For a 3-layer function, it's f prime of g of h times g prime of h times h prime. So do you see the pattern? It's like peeling an onion. Okay, that was a good analogy I heard when I learned the chain rule. The derivative of the outside, you're taking the derivative kind of like you're slicing the outside, or peeling the outside of an onion. Then you plug in whatever's left, okay? So when you peel an onion, you still have what's on the inside, right? Then you multiply by the derivative of the, say you have a 2nd layer, and you plug in whatever's left over after that. And then finally you take the derivative of the outside layer. You multiply by the derivative of the outside layer. Now you could have 4 layers, f of g of h of I. It'd be f prime of g of h of I, in other words, whatever's left over, times g prime of h of I, whatever's left over that, times h prime of I, times times I prime. You can see that, you know, there's a pattern, and you can do as many layers as you want. Like I said, though, we will generally stick to 2 and 3 layers. So let's go ahead and take a look at the first example. Okay, so we have y equals sine of x squared. How do we know that we are going to use the product, the chain rule? Yeah, we're going to use the product rule too. I mean the power rule. The chain rule, because we have x squared, it's a different type of function than sine, and it's inside of sine. So we have a function inside of a function. Now we're using y in this case. You could also use f of x. It means the same thing. And y prime means the same thing as f prime of x. So let's go ahead and take a look at how to find this derivative. So the way I teach my students this, I think is the best way, is to label each function that we have. Like I said, we have a sine function and an x squared function, so we're going to label them as such. As we talked about before with the complex derivatives, though, always make sure, if it's possible, make the derivative easier. Now in this case, we can't simplify sine of x squared. If we could, we would certainly simplify it to make it easy on ourselves. So make sure to make the derivative easier before you move on to the next step. Step 2, we're going to determine the rules. Notice these are kind of the same steps as before. We always want to figure out which rules we're going to use when we're taking the derivative. So right off the bat, we have a sine function. We know we're going to use that trig rule, trig derivative. And we also have a x squared function. We know we're going to use the power rule. Okay, so now we know which rules we're going to use, and we're going to use the chain rule because we have a function instead of a function. Let's go ahead and label our components. From the outermost to the innermost. This gets tricky sometimes, especially when we are dealing with exponential functions, but we will talk about that in a future example. The outermost function we can clearly see here is sine. The function inside of that we're going to call g. So the outermost function we will call f, the innermost function we will call g. Simple enough, right? Because x squared is being plugged into the parenthesis. Now when you label your f and g though, you want to write out what the basic function is, and this is certainly true for the outside function. We realize there's an x squared inside of sine, but just the basic function itself is sine of x. So whenever you have a bunch of variables, you just replace it with x itself. And of course the inside is whatever's inside, which is going to be, should just be x squared, not 3x squared. Okay, so our inside function is x squared. So now we're going to take the derivative of each of those things. The derivative of sine is cosine, which is our outside function. The derivative of our inside function, x squared, is 2x. So that's step 5, find the derivatives of the components. Okay, now we're going to write out the formula for the derivative of a function inside of a function, which is f prime of g, so you're plugging in g, and for x inside of your f prime function times g prime. Then we're going to plug that stuff in. So notice, what was f prime of x? F prime of x was cosine. The way the chain rule works is we're plugging in g in for x. And so I actually like to show that step. I'm plugging in g of x every time there's an x in f prime. And so the way that would look is, since f prime is cosine of x, I'm plugging in g in for x, so it's cosine of 3x squared. And then according to our chain rule, then we multiply by g prime. In this case, we figured out was 2x. So the second part's not so hard. You're just multiplying by the derivative of whatever the inside function is. But sometimes labeling that can be tricky and plugging in g. So you plug every time there's an x in your derivative function, you're plugging in whatever your original g function is. Okay? So we're plugging in, and that should say x squared. I meant to fix that. You're probably confused by that. So you say cosine of x squared. Okay, so it's f prime of g, which was x squared, times g prime. And then next step is to simplify. So if you can simplify it at all, go ahead and do that. You might want to move the x out front. Some people prefer that. I don't mind if you leave it that way. But that's it, and that should also say 2x. I had mixed up my questions here. I apologize for that. So cosine of x times x squared times 2x is your final answer. It's f prime of g times g prime. Just plug in g in for x and then multiply by the derivative of g. And in the next video, we'll look at example 2.